Good afternoon to you. Mark's out of HurricaneTrack.com here. It is now Wednesday, the 26th of July, 2023, in Phoenix, Arizona, getting ready to wrap up our workout here. Myself and colleague Mike Cornelius testing our Starlink system extensively, bonding that with cellular. We did some streaming testing, documented some of the monsoon activity, which, by the way, of course, is going to pick up after I go home. I fly home tomorrow. Mike is going to fly home in a few hours. And then afterwards, there's going to be lots more showers and thunderstorms out here, and I'm going to miss it. But the tropics are starting to get more interesting. That's what I need to start focusing on more. So timing will work out just fine. All right? So yeah, that's the bulk of today's discussion, is this favorable pattern for Atlantic development that is coming up. I'll try my best to explain it to you. So let's get started here. First of all, we lost those X's, the one that was here and the one that was down here. That was 95L. Those are gone, but that doesn't mean the weather entities that were causing those to be, displayed by the Hurricane Center, those are not gone. We'll look at that more in detail in just a minute. This one is still here, though. 30% now for development over the next 7 days. A complex setup, but overall the Atlantic looks like it's going to be more favorable. And I think this has a pretty good shot at becoming our next named storm out here. I'm starting to be more convinced, even though not much guidance except the GFS is showing it. We'll see. Maybe I'm going to get fooled again, but I'll show you the evidence. I'll show you, we'll see where the evidence takes us, right? Satellite animation here. Well, these are our features. There's what was outlined yesterday. Complex area of surface trough combined with an upper level low, actually a pair of them in the vicinity. Lots of convection down there, shower and thunderstorm activity over that very warm water of the Bahamas and approaching South Florida. That's what's left of 95L. This will probably make its way over towards Central America, and eventually some of that energy could get into the Eastern Pacific, where it might make an attempt to develop. But I want to draw your attention to this again. Very remarkable that we're not seeing any hurricanes out there right now. No tropical activity at all in the Eastern Pacific. And if it's going to be a big El Nino year and a low Atlantic hurricane season, well, you would expect to see a lot more hurricane activity in the East Pac, and we see none. And I think we're getting ready to get Emily, that's the next name, in the Atlantic in the next 5 days or so. All right, looking out to the east a little bit more, or maybe even a lot more, right? Yes, there's still a lot of dry, stable air out here, but this tropical wave and all this energy coming off Africa, this might have the goods, and it's going to couple with, or at least favorably interact with, what we call a convectively coupled Kelvin wave, a rather complex phenomenon to describe. I often say that it's like a shot of Red Bull that comes across the Atlantic and gives it like a boost. Usually it's a couple of days after the passage of this Kelvin wave in the atmosphere. It's got reduced wind shear, increased moisture, more convergence at the surface, and it's a temporary setting, just a few days, but it helps to get these systems going. Oftentimes it kind of fosters that, getting it over the hump, so to speak, because there is a lot of dry air still in the mid-levels out here, but that Kelvin wave kind of comes along and seeds everything, kind of like, talking about the desert Southwest. Sometimes you see this in Hollywood movies and TV shows where there's a truck spraying the water on the highway. I don't know what they do that for, but I guess they do that. And that's kind of like what these Kelvin waves do. They come in and they make a more moist environment. The whys, the hows, the mechanics of it, that's too much to go into today. The bottom line is this Kelvin wave, you can't really see it on a map. I can't draw it for, there it is. But it passes through. It's an atmospheric phenomenon, smaller in its time scale and its geographic extent than a much larger favorable pattern that we know of as the Madden-Julian oscillation, the MJO. That is different. That's a larger scale area of upward motion in the atmosphere, generally lighter winds in the atmosphere in the upper levels and a more moist environment. The Kelvin wave is a faster, shorter time period, and I think it's going to, the one that's coming through is going to favorably interact with this. I'll at least be able to show it to you on a diagram here, a map coming up shortly. All right? Trying not to lose you here. There's a lot of details in all of this that I think will lead to a more active period coming up. All right, vorticity-wise, there's our stretched out area in the Bahamas, a little bit of troughiness here, stretched out, vorticity as it were, nothing bundling and concentrating. Now there's X95L down in the Caribbean, and again, that energy could scoot on across and eventually try to make something of itself in the Eastern Pacific. And then there's all the energy waiting to come together out in the Eastern Atlantic, and that's going to be really interesting to watch over the next several days. We can see it even better on the Mimic total precipitable water product here from the University of Wisconsin. Look how far north, 20 north now, latitude, we are starting to get some of that moisture. It's got to work its way up into the mid-levels of the atmosphere. We're not quite there yet, but this is certainly making progress. The blues up here, that is definitely more drier air. That's confined more north now, north of 20 latitude. So here is that moisture area, a little bit of rotation in there. With the monsoon trough, you've got basically the African easterly jet that comes off this way, and then the low-level wind flow is coming like this, and you get a little bit of turning in there. That monsoon trough, a reversal of the wind flow, the wind pattern out there, helps to sort of jumpstart these systems. Then there's 95L, what's left of it anyway, and then our moisture over here, and again, everything's kind of stretched out for thousands of miles across the Atlantic, with it kind of trying to bundle there in the Southwest Atlantic, in the vicinity of the Bahamas, South Florida. That will bring some rainfall. I'll show you that in a moment on a radar animation that I've got for you from our friend Dr. Mark Nissenbaum. But first, I haven't shown this at all in a long time. I might not even have shown it last year. There are different products out there where you can kind of look at a diagnosis of what's happening, diagnostics or a diagnosis, whichever way you want to look at it. How's the Atlantic doing? And all these little thumbnails here, I'll try to explain as best I can. Some of them are kind of complicated, but I want to point out a few key ones that I think are big as we go forward. All right, so let's drop me out. And first of all, let's look at the Caribbean. Okay, so let's look right here, the Caribbean, and these are your different diagnostic tools, is a good way to look at it, of how things are going. You've got your probability and your relative vorticity, and then other things like vertical wind shear, instability, the mean sea level pressure over here, and then your sea surface temperatures and how they are responding and working with the norm, right? And that's what this line is. Well, let me just click on one and I'll show you, all right? So let's look at the Caribbean first, and let's look at vertical wind shear. We'll open this in a new tab so we can keep up with everything. So the Caribbean vertical wind shear is just a little bit above, well, we got to make it where we can see it, right? So let's use green. It's a little bit above where it should be, so it's a little higher than normal, but it's mostly been, and a lot of it here from June through July, a lot of periods of time there where it was way below normal. You would expect in an El Nino to see it like way up here, especially as we get towards peak season. So that's going to be interesting to watch. The fact that it's kind of close to normal, and it's hard to see, but it's come down right there. There's just a little bit of a dip. So vertical wind shear in the Caribbean, not excessive. Again, an El Nino would normally make it quite unfavorable, and the vertical wind shear would be much, much higher. All right, vertical instability, that's very important in the Caribbean. It's below normal right now, meaning there's a little bit of dry air in there. A couple times recently, it's been right at where it should be. So this line here, that is your mean or your normal, if you will, right? And so this is below normal. Below normal instability means that the atmosphere is too dry. That's a good way to look at it. So let's look at the tropical Atlantic, all right? So the tropical Atlantic, and I got to keep up with what's what. The vertical wind shear in the tropical Atlantic, this is very important. It is way below normal there. I mean, wow. And it has been below normal for quite some time. Now, as I recall, when all this talk of El Nino was coming, you would see a headline of El Nino expected for 2023. El Nino typically reduces Atlantic hurricane activity. Why? Because of increased vertical wind shear in the tropical Atlantic. No, this is the facts. This is what's been measured. All right, these are the diagnostics I was telling you about. The vertical wind shear is lower than normal. Now that's just one piece of the puzzle. All right? If we go back and we look at the vertical instability, that is also lower than normal, but in this case, that is a negative for tropical cyclone development. And that means that the atmosphere is quite dry, and we have not seen it. It got close to normal here way back in the spring, but it is definitely kind of dry out there. That's what this is showing. So this is a helpful tool just to gauge kind of how things are going. And you got a bunch of different parameters. Let's just look at the mean sea level pressure real quick. That's also a big indicator, and it's pretty much right where it should be. We had some higher pressures recently, and that's been going all back and forth, as you can see. Finally, the last one, we've talked about it over and over again, and this is just a great way to look at it on a plot instead of a map necessarily, right? The Atlantic sea surface temperatures from the Reynolds method, way, 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 way above where we would expect it to be. And of course, we knew that already, but that's just another way to look at it instead of just a map with colors all the time. All right, let's look at a few tweets. I'm going to still call them tweets because it says right there, tweet. It doesn't say X. Anyway, deep tropical moisture, this is from Andrew Moore, OSU weather guy, is interacting with a pair of upper level lows, that's what I was talking about earlier, to produce a large area of disturbed weather over the Bahamas and South Florida. Nothing to be concerned about. I think that's important to note from a tropical development perspective, and this should just provide some beneficial rain and some heat relief. I saw where it was just unbelievable down there yesterday in South Florida. Some of my colleagues and friends down there just like, we're done with it. And by the way, just real quick, I'm sure you've heard about the record warm, like over 100-degree water at Manatee Bay or whatever it was called. You just have to put stuff into context. Media, social media makes things bigger because there's no context. Stuff escapes. The genie escapes the bottle because of a lack of context. If you have a small, dark-colored dish that has water in it that's about a foot deep, and you sit that out in the Florida sun, or the sun anywhere where it's in the south, right? And then you have a very large Olympic-sized swimming pool, which one of those is going to get to 100 degrees faster? Or you get the idea? That little bowl, especially if it's dark-colored, is going to warm up much faster. It's shallower, it's easier to heat. Come on, all right? The area that this was measured is shallow. We're talking about 5 feet. It's kind of mangrove-ish. I was down there with my family on vacation in the Everglades, not too far from that site, and the guy on the airboat tour was from Chokoloskee, has lived there for his whole life. He knows the area. He was talking about how that very warm water, this is well before all this stuff started to come out, right? He was already on top of it, that ridiculous warm water, he said it was already in the mid-90s, and it's right there at the surface, even some of the deeper parts of the Everglades. But once you go down just a few feet beyond that, what we call the thermocline, it does cool off dramatically. So it is important, and it is happening, and it is very warm down there, and more so than it should be, but you have to understand the context. Out in the open ocean, we're not getting 100-degree water temperatures, or most marine life as we know it would simply die, and we don't want that. So just mark here trying to smooth things over. It's not as bad as it sounds, but it is still bad. We don't need water temperatures in the 90s. That doesn't do anybody any good. You know, come on. 85, I'll take that. Beyond that, no thank you. All right, back to the task at hand. Miami radar, as Andrew was talking about. Yep, there are some beneficial rain showers coming across. And hey, that ridiculous water temperature that was measured like right in here, let's highlight it where we can see it, Mark. White should show up pretty well. That was around in here, if I'm not mistaken. Go out and measure it after this. Seriously. Somebody should do that. I think it's in the national park. It's not even the National Weather Service or Ocean Services sensor. I think it's part of the National Park Service. But anyway, if you're down there, water temperatures will probably be down in the low 90s or upper 80s after this in these very shallow and easily disturbed areas. All right, try to keep going here. I just had to get that off my chest. I thought, come on, let's talk about this in the right context. This, too, will be really interesting to watch speaking of temperatures, very, very warm here, 31, 32 Celsius. As this disturbance does mix things up, let's take a look at this maybe on Friday. I got to travel home tomorrow, so no video tomorrow. But watch this down here once we look at it on Friday. I bet this looks different because the water down there is shallower. It is easier to heat and quickly to cool, but it's still going to be warm and enough so that we need to be keeping an eye on it once, some tropical activity perhaps tries to take advantage of it. Nothing yet, though. All right, our good friend Yakov here, we know him from over at Storm 2K, and he and I have interacted quite a few times privately on the old Twitter messaging and so forth. Very reliable source of information. And he says, and this is what I was talking about, that the other aspect, or he says specifically another aspect of the East Atlantic wave, the one thing it has going for it is the convectively coupled Kelvin wave, or CCKW, will be passing by the Central Atlantic by about Friday. 2 to 3 days after the passage of one of those Kelvin waves tends to be the most favorable for tropical cyclogenesis by encouraging convection and reducing shear. That's what I was just telling you, right? So in about 5 days, it looks like it's going to be quite favorable. Remember that, okay? And you can kind of see it if you understand these maps here. They can be somewhat confusing. These are the Hofmolar diagrams. This is your Kelvin wave moving across, and then you have to look at the time frame over here, and then where it is on a map is over here. So it gradually moves from west. This would be west. This is more east. See, west over here lines up, and then it ends up over here east, and then your time is over here, right? I know how to look at it. Hopefully that makes sense to you. But that green is favorable upward motion. That's your Kelvin wave moving across this way. That's how you interpret that. All right? All right. So let's see. You remember what Yakov said there? At about 5 days, things start to become more favorable. Where? Right out in here. You can't see the Kelvin wave on a map, but you can see when it has its influence. So let's just do that. Let's just march this thing out. 24, 36, 48. Hey, look, it starts to develop. At least the GFS says so by 60 hours. And then by 5 days, oh boy, it is definitely feeling more favorable conditions that are left behind as that Kelvin wave traverses the region. So it starts to get going, at least according to this one model, out here, and then gets more favorable, at least the environment should be, by day 5, comfortably away from the northern leewards there, right? And then by days 6 and 7, since the Hurricane Center's forecast does go out that far, I went too far, it does develop further south and east of Bermuda. A little bit of a weakness seems to move off of the U.S. coast, and that gives it a pattern to possibly turn around the Bermuda high, the Bermuda Azores high, more Azores this time. Does that mean that's what's going to happen? Not necessarily, just like it doesn't mean when you've seen those runs the last couple of days where they run right up the East Coast that that's going to happen. This is a week out. We will have to wait and see. One thing to note, the longer it does take to develop, usually the more west it goes. I would expect that this would correct more west with time because we're getting towards August now, and it's going to be hard to get really deep troughs off the East Coast to just yank these things out that easy. Certainly can happen, but don't put all your money on it just yet, and certainly you're going to want to watch this in Bermuda. And finally, the surf community, if this develops exactly as the GFS is depicting, it could be a pretty good surf period coming up, although that'll come with hazards too with the swells. We'll deal with that, rip currents and all that. We will deal with that as we need to. Finally, as we get close to wrapping things up, there's our disturbance in the southwest Atlantic that Andrew Moore was talking about that I was showing you on earlier tabs up here. Let's move this out into time. It does try to flare up there in about 30 hours, getting close to Melbourne area, just south of Canaveral, and then right over that area. So maybe squally weather headed in, and then it finally comes in, that little vortex right there. This is what we're talking about right here. So a little bit of a squally, rainy period, maybe some heavy rain at that. So if you're heading down to Orlando or Miami or whatever, starting Thursday and Friday, tomorrow and Friday, yeah, it could be pretty stormy and rainy, very heavy rain too. High precipitable water. Yeah, so be careful, all right? All right, as we wrap things up, like I said, been out here for the better part of a week, testing equipment, tracking the monsoon. Got some hail yesterday up in the south rim of the Grand Canyon, not far from the Grand Canyon Village. We were heading out of there, Mike and I. Couldn't believe it. It was like pea-size and a couple of marble-sized hailstones. Lots of lightning. Didn't see any fires started, thank goodness. There are a few wildfires in Arizona that are currently being battled. But the excessive heat still going on yesterday in Phoenix, 119. As, of course, is typically the case when you chase storms, that term I use loosely. When you leave, there's an uptick. That seems to be sometimes. I've had pretty good luck over the years. But in this case, I'm leaving tomorrow. Got to fly home. Lots to do. Got to get ready for those hurricanes that are probably coming, right? I think we're going to see an uptick in the monsoonal activity out here. And I can show you, just look at Phoenix on the Weather Service shot here, the site. Well, this is northern. How did I get Flagstaff? Not that they don't matter, but I wanted to show you Phoenix. So we're going to have an increase in thunderstorm chances, it looks like, over the coming days. If we click on Phoenix down here, it shows up pretty nicely in their, what do you even call this? I forgot the correct term. 20 to 30 to 40%. You say, well, that's not much, but for here, that's pretty significant. Finally, by Sunday night, 50%, Monday, 50%. See what I'm saying? I'm going to miss all that. But that's what Twitter is for. FOMO, the fear of missing out. You just watch on Twitter, and you can see what you missed. All right, so I have also told you about our new partner, Quick Dams, and I'll get rid of me in a second. This is just one of their many products. I say fight water with water. I came up with that, not them. And I think it's a good one there. As they say here, tired of fed up with floodwaters, waves, and buckets of rain creeping into your space, you can get one of their products, the Quick Dam Water Curb. You fill this with water, and you're all good to go. Compact, reusable. The water curb defends against fresh and salt water. Some of their products are not usable in salt water. We'll talk about that more later. This is going to be a long process, introducing you to this company, working with them to educate you about flood mitigation, because flood waters are the single largest source of our problems. They are very, very prevalent, and not just from weather, but burst pipes, spills, that kind of thing. QuickDams.com. Yes, they are a sponsor of our work, but also a partner. A sponsor, they say, here is X amount of money, put our logo on stuff, and maybe mention us, hey, we're sponsored by so-and-so. That's all well and good. What I like are these partnerships like I had with Lowe's for many years and Sprint for many years, where we work together and we actually educate our customers. You're one of my customers, right? We're all in this together. And so introducing you to the concept, more thinking about flood mitigation and having Quick Dams as a partner with that. We're going to learn a lot together, and I can't wait to show you more of what they have. It's going to blow your mind. It really will. So there you go. I'm going to pack up, get ready to take Mike to the airport, and then I fly out of Las Vegas tomorrow, and we'll wrap up a long week out here. All right, you guys have a good rest of your Wednesday. I'll be flying tomorrow, so no update tomorrow, but you bet I'll be back Friday. I'm Mark Sudduth, HurricaneTrack. Thanks for watching. We'll do it again Friday.